Hi everyone, my name is Andrés Olivos and I'm the Chief Innovation Officer from Olivos Riego, a company with almost 40 years of experience in designing and installing irrigation projects. First of all, I would like to thank you to the Almond Board of California for inviting me to this presentation. And I would like to present today irrigation design the Chilean way. First of all, the list of topics that we are going to cover today. First, I would like you to put you in context how the almond industry is in Chile. Then we are going to discuss a little bit what we think is a good irrigation design and the criteria behind it. Then I'm going to show you some examples, conclusions, and do not forget the bonus. Okay, so almond in Chile. So as you see the table on your left, Chile is not a good almond producer. In fact, 2.6% of the total fruit and nut production corresponds to almonds, with only 9,000 hectares. And personally, in our company, in the last 6 years, only 355 almond acres have been designed and installed. In fact, there are some years, in the last 6 years again, like 2015 and 2018, that we did not install almond projects. However, that's the irrigation design process still very common in all our fruit and nut projects, irrigation projects. So what we think should be a good irrigation design? In our company, we believe that a good irrigation design is a balance between the agronomy, the operation of the irrigation system, and also the hydraulics behind the design. However, growers in Chile pay a lot of attention in the agronomy part of it. So in the agronomy part of it, they pay a lot of attention to soil variability and soil characteristics. Soils in Chile are very heterogeneous, so that plays a key role at the moment of designing an irrigation project. Also, soil characteristics may have some influence, and less in this agronomy part, the application rates species and weather variability. In terms of automatic systems and telemetry may have some incidence in a good design. Also, harvest may have some incident especially in the row length in the design. Hydraulics, slope is very important in Chile. Just a data for you, in the Central Valley, the average slope is about 2.5%. That means that in 100 meters, there is a difference of 2.5 meters, and that's an average. Also, telemetry may have some incidence in how you design and how you plan your hydraulics. So what about soil variability? Soil variability is the main driver for irrigation block design. Good growers assess the soil prior to planting, and they determine their own homogeneous blocks, or what they think they are homogeneous. Soil is analyzed through different methods. Soil pits, as you see in the pictures on the left, through observation and also description by a soil specialist is very important. So in these pictures, they show the same orchard. This is a 100 hectares or 250 acres orchard, and you can see how different is the soil in different parts of the orchard. This is prior to planting. You can see some pits that have really deep soils and well-drained soils, and in some others, like this one, you have a water table like at 30 to 40 centimeters, and it filled up with water just only 30 minutes after we dig the pit. You can see also some gravelly with high organic matter, and then you have like a medium drained soil like this one. Other method used by soil analysis to analyze soils or the heterogeneous soils is soil analysis. So we take samples from the orchard and send it to the lab and start to decide how we are going to plan our irrigation blocks. And there are some other more technological methods and indirect methods like the variability or the EM38 that I'm going to explain later. In this example, the grower used the three methods. So he dug 20 salt pit, and we have 20 salt pit descriptions in 250 acres. That is 12.5 pits per acre. We took 60 soil samples in the 250 acres, that is 4 samples per acre, and we took easy measurements using the very system every 30 centimeters and down to 90 centimeters. The results or the output for such a nice study is this one. First, you go with this very system, which is an EC emitter that goes down up to 90 centimeters and takes samples or take measurements every 30 centimeters. Then with a data logger, we get information, the GPS location, and also the value of every measurements. We take the 58 soil samples that you can see in this black dots in the map. We take samples for those locations, and we determine soil parameters such as the percentage of sand, clay, the moisture retention at field capacity, and the moisture retention and wilting point. So you see the variation here between between each soil parameter and the coefficient of variation, and you can see that the coefficient of variation is very high. So after we get all this data, we try to do some homogeneous irrigation blocks here, in which we determine that in this 100 hectare, 250 acre orchard, we separate the orchard in 5 homogeneous irrigation blocks. So that means 50 acre per block. And then we also define our fertigation blocks, which is even more variable, and we define 16 fertigation blocks with a 16 acre per block. What about the application rates? In Chile, most almond orchards use drippers as emitters. This is using a double drip line. It's not common to see in Chile micro sprinkler irrigation. The water demand, highest ET, it's about 7 millimeters per day. That is a 0.28 inches per day. Commonly, hourly application rates vary from 1.5 to 2.5 millimeters per hour, or 0.059 to 0.098 inches per hour. That will depend also on the soil infiltration. Daily application rates vary from 8.75 to 10.5 millimeter per day, that is 0.34 to 0.41 inches per day. That will depend on how the grower is going to apply the water weekly. Sometimes there are some conservative growers that they don't want to be really tight on their schedule. That's why they give a higher daily application rate. Normally, irrigation blocks vary from 4 to 6 per irrigation line, with 6 to 10 hectares or 15 to 25 acres per block. And they may have multiple irrigation lines from 20 to 45 hectares, or the same as 50 to 110 acres. I would like to explain a little bit what we call an irrigation line. An irrigation line is the system required to irrigate a certain area efficiently. The irrigation line is composed by independent pumps, filters, and water meters that can run simultaneously. In Chile, the area that covers one irrigation line is about 20 to 45 hectares, or 50 to 100 acres, and 4 to 6 irrigation blocks. An area larger than 45 hectares is divided in 2 irrigation lines with about 22.5 hectares each. In the example here on the left, there are 4 irrigation lines that cover 100 hectares, 250 acres. So what we mean here is that we have 4 independent irrigation lines that can run simultaneously, so we don't go with higher area. So let me go through some examples. All these examples belongs to an almond orchard. In this case, the total area is almost 25 hectares, that is 60 acres. It is divided in 5 different irrigation blocks. That's number 1, the green one 2, purple 3, 4, the light blue, and the dark blue is number 5. In this orchard, they have 3 different plant densities: 7 by 5 meters or 23 by 16, 20 by 16 feet, and 21 by 13 feet. Even in this project, we have block number 5 that belongs to peaches, which is really common in Chile. This is irrigated by the regular double drip line with 2 liters every 50 centimeters or 0.53 gallons per hour every 20 inches. An hourly application rate ranging from 175 to 1.89 millimeters per hour, that is at 0.069 to 0.074 inches per hour. A daily application rate of 8.4 to 907 millimeters day. It has the largest block, which it is 6.45 hectares, 16 acres in total, with a highest flow rate of 101 cubic meters per hour or 440 GPMs, a pump power with 30 horsepower. Let's go to example number 2. A total area of 45, almost 46 hectares, 113 acres. Again, 5 irrigation blocks. To control this orchard, we have involved 24 control valves, one valve per 5 acres, two different plant densities, 23 by 13 and 21 by 13. In this case, we have both types of drips, regular and compensated double drip. The compensation is in this part of the orchard, in where you see that there's more slopes. We irrigate this orchard with 4 liters per hour every 65 centimeters. That is 1.06 gallons per hour every 24 inches. An hourly application rate of 1.75 to 189 millimeters per hour. That is 0.069 to 0.074 inches per hour. A daily application of 0.33 to 0.36 inches per day. Its largest block, it is 10.5 hectares or 26 acres. This, I would say, it would be the largest block that we design in Chile, 10 hectares, 10 to 12 hectares, no more than that. And the highest flow rate is 201 cubic meters per hour with 80 GPMs. The pump power is, we use 2 pumps here. First pump, which is 50 horsepower, plus a 20 HP in series for the highest blocks that I showed you before. A little bit different. And then I would like to show you an example of a largest area covered by almonds. This total area is in 80 hectares or almost 200 acres. It has 12 irrigation blocks divided in 2 independent irrigation lines with 6 blocks per line. In order to control, to open and close valves in all this project, we have installed 37 control valves, 1 valve per 5.4 acres. Plant density 6 by 7 meters or 20 by 23 meters. Everything here is compensated micro sprinklers, especially with the difference in elevation from this point to this point. We use 50 liters per hour, 2 per plant micro sprinklers. That is 13 gallons per hour. Our hourly application rate here is 2.38 millimeters per hour or 0.094 inches per hour. Daily application rate 9.52 millimeters per day or 0.37 inches per day. The largest block here is 7.8 hectares, 19 acres. Highest flow rate almost 200 cubic meters per hour or 850 GPM. In the orange irrigation line, which covered this area, we are using a 50 HP pump. However, this larger area here and more sloping one, we use a 75 HP pump. This means that as we have 2 independent irrigation lines, we can irrigate 1 block from the orange area. At the same time, we can irrigate 1 irrigation block from the green area. So what do we get from this? Some conclusion. First, we address soil variability, which is really important in Chile. Smaller blocks and more homogeneous. We can have some water savings. Increased number of valves. There might be potential operation problems, but we solve that with automation. We have some increased number of irrigation lines. We have a potential operation problem, but we also solve it through automatic controllers that can run more than one pump. We have smaller pumps, and also we have some smaller piping. We have more irrigation lines, so more possibilities to react to problems. We can have some bypass between the irrigation lines. I will show you some pictures about that. We can address some land topography. Chile's central valleys, as I mentioned before, have an average of 2.5% slope. Irrigation block can be smaller if high elevation, if we have some high elevation differences. We also have some flexibility to have multi-crop production, very common in Chile, different lines for almonds, prunes, walnuts, cherries. Would like to add some bonus, the automation. So here in Chile, at least our company, 100% of our projects are with automatic pressure regulated valves. Those can be wired or through telemetry. We actually use a hybrid system in where we put an radio transmitted antenna, and from there we can go to two valves with wires. So that means that we do it not that really expensive. We can control a single valve or a group of valves if hydraulic devices allows it. That means that I can irrigate a group of valves the way that I want, or I can open just only one valve. The telemetry has a dual purpose. That means that we can use it as a valve control to open and shut down irrigation blocks, but also the same antenna can have sensors, weather sensors, water content sensors, plant sensors. Also, on the automation on a pump station, we have some motor controllers that can have the capability to control several irrigation lines with only one controller device, making it really easy. And also we can operate and monitor irrigation system at the controller via web or mobile app. So how does it look? Let's imagine that this is an orchard. We with the same controller, we can control the filters and the pumps. We also can control the valves in the orchard, open and shut it down, irrigation blocks. With the same telemetry, we can monitor the weather, we can monitor the plant and soil, we can monitor also the well and canal, and we can run everything by only one visualization program that we developed here in Chile. It's called Olive, and we work basically with two big companies out there, Talgil from Israel and Pessel from Austria. I would like to end my presentation showing some pictures of automation. We see here a well monitoring system that is connected also to the cloud-based visualization. This is how a antenna, control valve antenna, looks like. It's autonomous. It has a solar panel and a battery over there. Here I would like to show you a picture of two irrigation lines. We also do bypass between them. So in places in where we can have some problems, we can irrigate this line with this other line. We just shut it down here, open it here, and water will flow from this line to this line. Here we're seeing some monitor of a canal, the flow rate of the canal. And also, in the last 2 years, we partner up with Florapulse, that is in California, to measure plant-based parameters like stem water potential with the microtensiometer. Well, that's it. Thanks everyone. Hope you like it. My name is Andrés Olivos, and if you would like to contact me, please send me an email to the email shown there. Thank you very much.